We are all set. Welcome everybody on our next webinar, Open Virtualization Pro. Let's just check and do the quality check. Let me know on a chat that you hear me well and see both of us. So with me, we have Jarek here.
Hello, morning.
Hello.
Good afternoon.
Good afternoon, good morning, depends,
Depends
from which time
where
zone.
you are.
Yeah,
Exactly.
where you are. Hopefully you sit comfortable, because in the next 30 minutes we have a plan to talk a little bit about how to securely deploy the application in DevSecOps. This is the problem, because there's a funny joke that you can be a CXO, so you can just put everything inside. You can be
Exactly.
CVO, CTO, CEO, and millions of the different options. This is the same what I see right now with the DevOps.
Yeah, exactly. You can put
So
anything
how many
in the middle.
combinations we have here?
Well, I have seen a lot of them, so hard to count.
Hard to count. So let's just see on the chat. Hi. Yeah. So I believe we can start right away. So I will just share the presentation. So what's the plan today for today, Jarek?
Yeah, so today I would like to give you some short overview about the best practices around securing your DevOps pipelines so that you can call them DevSecOps pipelines.
DevSecOps.
Exactly.
We need to okay, and what technology we will actually touch today, briefly?
Well, as usual, if you see me, it's gonna be based.
It's not a secret.
It's gonna be based on the OpenShift and some components that we have in OpenShift product family.
Great. So let's just briefly talk about ourselves. So Jarek, please go ahead.
Yes. Hi. So my name is Jarek. I'm solution architect at Red Hat. I'm with Red Hat for almost 9 years now. I focus mostly on the application technologies and DevOps, DevSecOps recently, everything based and related to OpenShift.
It's 9 years. I'm still thinking that it's just a few, not 9. So next year will be the 10th anniversary.
It will be, yeah.
We need to plan something for you here, mate. My name is Paweł Mączka. I'm co-founder in a Storware company. We are specializing in the data protection for the containers, virtual machines, and more. And privately, I always like to hiking and playing on my guitar with my company band or the typical band. So rock, hard rock, and the metal. But we'll not today speak about the music, but maybe we'll put or play some notes when we will deploy the apps.
Sure.
So let's move forward, Jarek, and see how to better secure the existing containers based on the technology that you present.
Yes. So we'll start with the so-called inner loop. So the inner loop is what developer is doing on his desktop or her desktop. And of course, we focus on the containerization. So you can see here that there are a number of tasks that a developer needs to execute in order to create and deploy and run containerized application service. So we need to start with creating some image definition. So here you can see on the left-hand side the container file example definition. And you can see that very important here is to really use some proven and secure base image, because typically you will not start your development from the scratch, but in most cases you will rely on some existing base images. And it is important to choose one that or set of images that have some vendor or some community that make sure they are secure. The next step for you will be to deploy your own code, and your own code also might be some sort of risk factor. So you need to make sure that you scan from the security point of view all the dependencies that are used by your application. So we have a dependency scan here step. Then, of course, you're gonna build the image. So you create a binary, and the next step here is to sign that image, to be sure that whenever it will be deployed and executed on some runtime environment, it will be really the same image and not another image that has the same name, because sometimes this makes a big difference. And there is one more step here. So when you create an image, you sign it, you push it to the image registry in most cases, and you should also make sure that the binary image is scanned against some CVEs. And here what is very important is that you execute that scan continuously, because day by day some new CVEs are revealed, and it is very important that you can detect that your image might be or is or not is vulnerable to some specific CVEs. And if we jump to the next slide, I just put here for your reference some components, some names of components that we typically use at Red Hat to provide those capabilities. So you can see the base image. Of course, we have a RHEL operating system, so we provide RHEL-based images, but also we provide UBI images, which are totally free of charge, are based on RHEL. They contain some subset of RHEL capabilities, but in many cases they are good enough for you to use, and they have the same security policies as RHEL. So you can, if you trust Red Hat, and I hope you do, you can rely on those images to create your own application images. Then we have CodeReady workspaces, which is basically an IDE that we provide with OpenShift, so development environment, but it has a dependency scanner that allows you to scan the dependencies of your applications. Then we have the SigStore. So SigStore is a project. This is the name of the project that aims at creating infrastructure for signing and verifying the digital signatures of different resources. But in our case, of course, we use it to sign and verify the signature of our images. And then we have last two components, very important. So Quay, which is an image registry that has built-in image scanning capability, and ACS. So this is abbreviation for Advanced Cluster Security, and this is a component that provides sort of full application lifecycle security monitoring. It also has, as part of its functionality, a scanner, but also it allows you to monitor your application through the whole life cycle. Yes, so building, deploying, and running applications.
Yeah, two questions. First one, is it a native configuration that you secure in the containers in this way, or you need to have some additional configuration on the OpenShift itself? Is by design, let's say, in the latest releases?
All those components are available as part of OpenShift portfolio. Some of them, of course, are also available as independent components, or like SigStore is basically a project at the moment, is the name of the project. So there is no any commercial here license or subscription required. But all of them are available, and I will show you in a minute how do they work in a real life scenario. Okay, so let's move on. So that was about the inner loop. Yeah. So if you are a developer, you want to make sure that you create a secure binary on your laptop or desktop, then these are basically the steps you should follow. But of course, in real enterprise environment or some organizational structure, we have typically a process, CI/CD, DevOps, whatever you call it, that is executed in order to deploy the new version of your application. And then even if you have a full DevOps practice, you also include monitoring and runtime, application runtime as a part of your pipeline. And this will require you to use a bit more components. Of course, those I mentioned, they will be also used maybe a bit in a different way, because typically they will be used they will be executed as part of the CI/CD pipelines. Yeah? So you will see in a minute that all those steps I mentioned before, in order to execute them, you will have a pipeline that really execute that steps. And if we move forward, because maybe I don't want to go into details now of this specific slide here, but because you will see this in a minute. But if we move to the next slide, here you can see sort of schema how and which tools are playing together in this DevSecOps pipelines that we typically implement in OpenShift. Yeah? So here you can see. I hope you cannot see my
Mouse.
My pointer, but anyway, you see maybe you know the Tecton logo. So this kind of cat. This is a CI/CD engine that we have in OpenShift, and we typically use it to implement the continuous integration process. So within this process, you can see that typically this process is triggered by commit of new version of your code into your Git repo. Nowadays, we typically standardize on the Git as a source code repository. And as part of this pipeline, we create two, let's say, deliverables. Yeah? So the first one are images that we store in the queue. So you can see on the right-hand side, there is a queue registry. And we also create here application configuration, which we store in the Git repo. However, typically this is a different Git repo than the one that you use as a source code repo, or at least it's a different repository. And this config Git repository consists the Kubernetes manifest that are needed to deploy your application into the OpenShift or Kubernetes cluster. And in order to implement this continuous deployment step, so that in order to deploy your application, we use Argo. Yeah? So you can see this sort of fancy octopus logo. This is Argo CD. So
some kind of the cat, sexy octopus.
Fancy,
fancy,
I would say. Yeah, so and this is the second component here that we use to implement the continuous deployment step in our pipeline. And then here on the right hand side, you can see the advanced cluster security. So our sec component in our DevSecOps pipeline, which we use in basically every step of our CI/CD process. As you can see, we use it in a Tecton to analyze the images, to analyze the Kubernetes manifests from the security point of view. We also use it to scan images that are stored in queue in case there are some other images that we want to use. And also it is used to monitor our clusters, our OpenShift clusters, to make sure that the cluster configuration, not only the application configuration, is secure. And maybe if you have such requirements, whether it is compliant with some industry standards like PCI or even CIS or some similar. And basically this is what I would like to show you now quickly in the second part of our meeting during the live demo presentation. So let me just share my screen first, and yeah, hopefully you can see this screen.
CodeReady, yeah. Mm-hmm.
Yeah, so this is a CodeReady workspace. So the IDE I mentioned, so the development environment, it is included in OpenShift. The funny thing or interesting thing about this IDE is that you can see here on the top that I run it in the browser, so you don't have to install any IDE locally on your desktop, but you just open a URL and the code editors are opening. But in today presentation, we don't want to learn how to code, but we want to see that CodeReady has a dependency analysis component that will in the real time detect any CVEs, any security vulnerabilities that are included in your application dependencies. So here we have an example of Java application. So we have a POM XML file, but the same way it will work with Python or many other languages. So you can see here I have a highlight that I use as a reference well-known Log4j library that has number of vulnerabilities revealed, and this is very quickly spotted by the dependency analysis component, and I receive quickly a recommendation to switch to the other version that is secure. The same with latest Spring vulnerability that was revealed just a couple days ago.
It's not the money, but also the recommendation. Yes.
Yes, it is recommendation,
Mm-hmm.
and I can apply this recommendation directly from in my IDE.
And what if you'll use the external development IDE and not the CodeReady?
Well, if it is up to this IDE to provide this capability, yes, I'm showing you how you can do it with in CodeReady. I will show you in a minute how can you execute the same step task in the real CI/CD pipeline. So this is you can see that as a developer, and basically this concept is called shift security left. Yes, so we try to detect any possible vulnerabilities as quickly as possible, and this is basically the first I would say the first possibility that developer detects himself if he has the right tools, whether some dependency of his application has some vulnerability or not. So here we are relying on the dependency analysis provided by Snake, so well-known company that's kind of is specialized in this type of analysis. So you can see that for every project I can generate this kind of report where I can see more details about the vulnerability if this is not so obvious like those two that I have shown you. But of course, as you said, not everyone will use CodeReady to develop applications. So other option to execute the same analysis is to add it into your pipeline. So here I switch to the next screen. You can see this is a OpenShift Web Console, and this OpenShift cluster has enabled and installed the pipelines. So this is based on the Tecton project. And here I have some kind of sample security oriented, so DevSecOps oriented pipeline. And here I have number of steps, and basically the first one I'm executing here is exactly the same as you have seen in CodeReady. So I'm going to execute this dependency scanner. So before I continue, I will just start this pipeline because it will run for a while. So you can see here, this is just nice UI for the for the tecton here. So I just need to provide some parameters quickly here. Also, it's too fast. This is our workspace where all the computation will be done. Here I have to specify the Maven settings to use my mirror. I don't need those images, and I need to provide my Git secret with my Git credential. Okay, so let it run, and we can now continue. So so the first step, security oriented, is this dependency analysis. The same as you have seen in CodeReady, just executed here in the pipeline. Then what else we have here? We execute some Maven-based unit tests. We build our image, new version of the image containing our application. We push it to the QA images registry, and this registry will execute for us the scan, security scan, but also we will execute the scan here in our pipeline. And here we will leverage this advanced cluster security. Yes? So you can see here I have two tasks. One of them is executing the scan. The second one at the same time will check if there are any configuration issues in my image. So for example, if I use some strange naming or something like that.
And this is the base workflow pipeline here, or you needed to design it?
Yeah, it is my opinionated.
Okay.
However, it is based in most cases it is based on available definitions of the tasks. Yes, so we have here, I will show you in a minute, just I will finish showing this pipeline, that there are some tasks that you can reuse in your own pipelines. Okay, so then we have we sign the image. So we use the SIG store I mentioned to sign the image. The signature is also stored in the container registry, and then I update my configuration, my Git configuration of my application, so that my continuous deployment engine can start. And this will be a moment when we will, after the pipeline will be finished, we will switch to the Argo CD. So in Argo CD, I have set of applications configured, and the one we are working on is the sample app stage. So you see now it shows the status synced, so it means that the configuration of the Kubernetes configuration of my application in Git repo is the same as on my runtime cluster. However, after the pipeline will be executed, new version of our application will be created. This will be out of sync, so you will see it in a minute. But so far we can come back here. So we see that dependency analysis has been executed. So we can check in the log. Here you can see I just for our demo I use just latest version of all the all the dependencies. So there are no any vulnerabilities detected. However, if there would be any, our pipeline would be simply stopped here, because if there would be any vulnerabilities with high or critical severity level detected, this pipeline would stop here. But in our demo, it is okay. Also, this tool creates for us also a report pretty much similar like you have seen in the CodeReady. So let's give it a second. So you can see pretty much similar UI. Of course, there were no any vulnerabilities detected here, so we have here nothing. But you can see that there was many different dependencies analyzed, both direct as well as indirect. So if you would have this, for example, log4j dependency or anything like that, you would see it here, and this would basically block our pipeline. So now the pipeline is moving forward. So we can see it runs. So I can show you now the task. Yes. So in OpenShift we provide set of so-called cluster tasks. So the big library of tasks. There is also a public registry of tasks that you can reuse in your own pipeline. So this is called Tekton Hub, and from this hub you can also download some tasks. So for example, this Red Hat CodeReady dependency analysis is a task that I have downloaded from the Tekton Hub, and I use it here in my pipeline. There are also some other tasks, as you can see here. So those rocks tasks, they are the tasks that are executing some security checks against our advanced cluster security component, which is based on the StackRox projects, hence the rocks prefix. So here we can quickly have a look on the ICS console. So again, ICS, as I mentioned, is quite comprehensive solution. So we don't have time today to go into the details. But what we are really using here, we are in our pipeline. We have steps that are making checks against the ICS policies that you can see here. It's a very long list of those policies. And those policies that have specified in their lifecycle tag build, these are the ones that are executed during the pipeline. Yes, so there are other like deploy that are related, that are executed when we deploy some application into the cluster, and at the bottom there will be also a runtime. Yes, so runtime policies are executed against running containers. Yes. So
can you show the details? What's behind the typical policy? Because I would like to understand how to create a new one.
Yeah. So in order to create a new one, you can basically start from existing one. So you can clone some existing, or you can start from the scratch. If we go into the edit view, so this is newest version, so I see here some changes in the UI, but basically what is important here, so the policy criteria, you specify behavior is here. You specify the life cycle, you specify the if this will be just the information, if the policy is violated, or should be also enforcement. Yes, so enforcement, for example, in context of pipeline, means that the pipeline will be stopped if some policy will be filed. So this policy, I don't have permission to edit, because this is out of the box policy. So we need to come back and make a clone. Probably this will give me more
options to change it.
Here you can see like that I can make some modification. Yes, so this is how it works. So on the right hand side you can see we have different metadata that is collected. So depending on the type of the policy, different metadata will be available. But for example, if you want to create a policy related to some image, you can see that here is some metadata of the image, and we can just drag and drop it here and make some make some modification. Yeah, so there's no any like language, or there's no development of policies. You simply just drag and drop and configure what you need. And if there is anything that you need that is missing, you have to call us, and we will create for you in the next version some additional metadata if this is feasible, and of course and makes sense. Yes. Okay, but anyway, maybe this is a good topic for other webinar. So for now, let's come back to our pipeline, which hopefully has progressed, or even has success, as you can see, has succeeded here. So we can check it. So here are those two tasks that are executed. Sorry, I have to go here. so that was a image check that it was checking whether the image is compliant with all the rules that we have seen in defined policies, defined in ICS. So we are fully compliant here. Also, there was a scan executed here, so you can see there was a number of CVEs revealed, but I believe here is one important. So so it means that our policy has not set the enforcement, but it was just the it is just in the informative mode. But you can see here that the libraries that are included in our image, they were scanned, and some vulnerabilities were revealed as per this report. Then we have a step of signing. So we use a Cosign. So this component, this is kind of CLI part of the SigStore project, and this has executed this task has created a signature of my image. We can also take a look here into the Quay registry. I will just need to refresh probably the browser. And here you can see a new version of my image 2 minutes ago also has been scanned here in Quay, fully independently from the scan that was executed in ICS. And here you can see we can see the signature here.
So first thing is to validate dependencies, then to be 100% sure that it's not compromised, but some external, let's say, third party that we sign out internally. Yes,
exactly. Yes. And here what is also important in Quay is that it will execute the CV scans continuously. Yeah? So for now our image is good, but in the future there might be some new vulnerability revealed, and Quay will rescan our image and will notify us that there is some new vulnerability, and this should be a trigger for us to re-execute this pipeline. Okay, so this pipeline has produced as a last step application configuration that has been stored in the Git repo, as well as the image you have seen in Quay. So now we can switch to the second tool, so the Argo CD, that is responsible for continuous deployment. Yes, so this with Argo CD we will manage the deployment of our application across all the environments that we have. So in my example, I have a staging, I have a production, test and production. Yeah, so because we don't have a time here, so you can see that the status has changed of our staging. So it has detected that the new configuration of our application has been created during the pipeline execution, and this has changed the state. So we can see here what are the artifacts which are part of application. So this application is super simple. So we have just deployment and the service, Kubernetes deployment and Kubernetes service. So now I can, as an administrator, I can manually trigger the synchronization task that will apply new configuration from Git repo to my cluster. You can see that this has been executed. Also, if we come back here and change to the stage project, we should see in the workload that the new pod has been created just now. So we can see that this has happened. The new version of my application has been deployed in fully secure fashion. Yeah, so we made sure that there are no any vulnerabilities in our application. We also signed our artifacts so that OpenShift can verify the signature if the image is really the one that we have created and not just the one with the same name. And I think this will conclude our demo for today. So I hope you enjoyed it and you had some feeling how to put all those things together that we have in OpenShift in order to build fully secure DevSecOps pipelines.
Looks really promising. The question is, how it works in real time, but the stack of the different technology. When I'm comparing even to other than CI/CD options, is you have everything in one place. And this beauty about the dependency in a SNCC integration gives you the real time information. Exactly. It could be a great trigger that you will not push your application into the production, then realize that you have a bunch of the different problems that you could you should be exposed before it goes into the production.
Exactly, and this is very important, as I mentioned, this shift security left. Yeah, so try to detect as quickly as possible any vulnerabilities, because the later you will detect them, the more time and more costly will be to fix them, basically. Yes, and more risky if you let them go to the production.
So right now I'm better understand the DevSecOps, the role here based on the technology that you provide. So team, we are after 36 minutes. We promise you the 30. So it's a great place right now to ask the questions if you have to Jarek regarding the section about how to properly secure and deploy the application. So please feel free to put it on the chat if you didn't put before. And Jarek, like always, what should be the best option right now to start the journey? It's only about the OpenShift, because I've seen the different names. If you could just give examples how to start the journey.
Well, in fact, all those components I have shown you, they are running on the OpenShift. Could be even on the same OpenShift cluster. So if you want to get started, just deploy OpenShift. Then there is a set of operators. In OpenShift, all the additional components are available as operators. So there is an operator for the Tekton, so for the pipelines, for Argo CD, so the GitOps. ICS also is operator, Quay is operator. So all those components you can put together get together as a set of operators installed on top of OpenShift, and then you can play with it. There is, I think, a lot of examples available, so you can either build yourself some pipelines or play with existing examples.
Great, thank you. So team, we would like to thank you for the participation in our live webinar. We guest Jarosław Stakuń. Jarek is shortcut in Polish, but I think
I have on my
you have on your shirt. So we
definitely
guest Jarek.
It works.
It works, and like always, was a pleasure to host you here. And let's think about the next. I think we could right now deep dive and stay on the security path, because I believe, especially nowadays, what's going on worldwide, and if we see that the cybersecurity is much more important topic these days, we will have a place to play around this topic. If you have some suggestions in which direction we should go on the next webinar with Jarek, just let us know on a chat, or if you're watching right now on YouTube, just put the comment. Again, Jarek, thanks for your time.
Thank you,
and for your specialization here, and great presentation and live demo. That was the Open Virtualization Pro webinar. So looking forward to see you on one of the next one. Stay safe and have a great day.
Bye-bye. Thank you.
Cheers. Bye.